Hello, calculus fans. So let's test this series, n squared over 2n minus 1 factorial for convergence. All right, we're going to apply the ratio test. We'll look at the limit of a sub n plus 1 over a sub n. So we get the limit of the absolute value of n plus 1 squared over 2n plus 1 factorial times 2n minus 1 factorial over n squared. So this is, of course, the a sub n flipped upside down. One question is, how did we get this? Well, we took the 2n minus 1 factorial and replaced n with n plus 1. Now we don't need the absolute value, everything's positive, and we'll reorganize stuff. And now let's try to figure out what's going on with this. Now remember what factorial means. You're multiplying 1 times 2 times 3, all the way up to whatever it is the number you're taking the factorial of. So 2n minus 1 factorial, we see that up in the top. And then in the bottom, 2n plus 1 factorial, well, you have to multiply everything up to 2n plus 1. So we have to multiply everything up to 2n minus 1, but then we have to keep going to 2n and 2n plus 1. And then the whole point of that is that the 2n minus 1 factorials cancel. This is something that's sometimes a little bit tricky to see. We might want to discuss this in class so that we see exactly how this works. Once those cancel, then you get this expression. And that limit is 0. How do I know that? Well, it's time to be a little grown up about limits of these types, limits of rational functions. The degree in the bottom is 4th degree. The degree in the top is a 2nd degree. So if the degree in the bottom is bigger, then we get a limit of 0. And that's smaller than 1. So the series is absolutely convergent by the ratio test. Okay, that's all for now.